Hello, and welcome to Module 3 and Week 3 of the Accessible Pedestrian Pathways mini course. I'm Rachel Byerly, Communications Director at NADTC. This week's focus is on pedestrian crossings, signals, and technology. This week's module includes a PowerPoint presentation, a required reading on accessible pedestrian signal installation issues, and a quiz based on the reading. In this presentation, we'll discuss types of pedestrian crossings, pedestrian signal features, piloting of interactive mobile pedestrian technology, safety features, and crossing innovations. Let's get started with Crosswalk Basics. The Federal Highway Administration's Manual of Uniform Traffic Control Devices, or MUTCD, provides guidance that crosswalks should be marked at all intersections that have substantial conflict between vehicular and pedestrian movement. In addition, crosswalk markings should be provided at points of pedestrian concentrations. The graphic at the bottom of slide 3 denotes the primary type of crosswalk markings that you'll see. These include a solid block of paint, which is standard, which is a parallel set of lines, the continental type, which is a row of separated white blocks, dashed, which is dashed parallel lines, zebra, which is a row of separated blocks set at a diagonal, and ladder, which combines standard and continental markings. Beyond the markings, let's go over the types of crossings. Zebra crossings are the original type of striped crossing, and this was first used in England in 1951. Pelican crossings involve a pedestrian-controlled signal. Pelican is a loose acronym for Pedestrian Light Controlled Crossing, and this is a situation where a pedestrian pushes a button to trigger the red light for motorists, and then a walking man or countdown signal appears for the pedestrian. Puffins, or pedestrian user-friendly intelligent crossings, are the next type of crossing. Puffins expand on the Pelican. Lights controlling pedestrian movement are set at a diagonal, making it easier for pedestrians to monitor both traffic and pedestrian signals at the same time. Sensors may be allowed extension of time, or they may shorten the time for pedestrian crossing if no pedestrians are detected in the crosswalk, making it more efficient for both pedestrians and motorists. Keeping with the bird theme, another type of pedestrian crossing is the Toucan, or two-can cross. Toucans are wider crossings that accommodate both bicycles and pedestrians. So, for example, in the photo on slide 6, this indicates parallel bike and pedestrian crossings in Seattle, and you'll notice the designated difference between the type of striping. And the bicycle symbol is shown in the area to be used for bicyclists. A type of crossing that's becoming more and more familiar is the HAWK signal, which stands for High Intensity Activated Crosswalk. The HAWK originated in Arizona, and the photo on slide 7 is from the Phoenix metro area. HAWK crossings have overhead signs that read "Stop on Red" and "Pedestrian Crossing." A flashing yellow light turns to solid yellow, which turns to solid red for vehicles, and it's also a signal for pedestrians. Flashing red lights indicate it is safe for vehicles to proceed after a pedestrian crosses the road. The last type of crossing we'll look at here is the pedestrian scramble, or Barnes dance. This is named after mid-20th century traffic engineer Henry Barnes. In a scramble, traffic is stopped in all directions. Pedestrians can cross in any direction, including diagonally. A scramble is used in high-volume pedestrian and traffic areas such as tourist locations, sports venues, or festival grounds. Here in Washington, D.C., we have a pedestrian scramble at H and 7th Streets in Chinatown, which is a high-volume pedestrian area and is also located adjacent to a sports arena. Newer pedestrian features that you'll see integrated into crossings include traffic calming and plantings, as shown, for example, in this slide's photo from Olympia, Washington, and that illustrates a pedestrian refuge area in a planted median island. Other newer features you may have seen include raised crosswalks, and sometimes they'll feature bricks or colors, more visible signs, road paint, and yield to pedestrian signs. The next few slides contain an overview of pedestrian signals. This information is available on the Pedestrian Bicycle Information Center website, which is www.pedbikeinfo.org. The International Pedestrian Signal is preferred, with movement away from the older walk, don't walk signs. Countdown signs are required for all newly installed traffic signals, and push buttons may be controlled manually or by passive detection. You'll also find places where detectors are located in some cities, as half of the pedestrians who are out there walking do not push the buttons to trigger the signal. As I mentioned earlier, the Federal Highway Administration Manual on Uniform Traffic Control Devices, MUTCD, Section 4 of MUTCD provides guidance on requirements for pedestrian control features, and this includes signal head meanings and locations, location and placement of detectors, walk indication voice messages in terms of what specifically the message should contain, extended push button features, and hybrid beacons and lighting. Accessible pedestrian signals are the feature of this week's homework assignment. APS, which is the acronym that's commonly known as, provides audible tones, speech messages, or vibrating surfaces. When APS signals are installed, they must meet Americans with Disabilities Act requirements. Marked crosswalks should be installed in conjunction with the signals. A traffic cycle length of 90 seconds or less is best for pedestrians, or otherwise they will get impatient and try to cross against the light. Countdowns help encourage pedestrian movement at the beginning of the cycle rather than having people wait until the very end. Signal timing must also take into consideration the turning time of trucks and buses as well as cars. Slides 13 and 14 cover signal timing. Signal coordination, so the first type of timing that we'll look at, is found along corridors with adjacent street light intersections. This would be typical in a downtown grid layout. So, for example, signals may be set for vehicle speeds of 25 miles per hour with the pedestrian signals coordinated to the speeds of the vehicles and the overall signal coordination of the traffic. Concurrent phasing is when a pedestrian signal activates with a parallel vehicle phase, and this permits vehicles to turn left or right across pedestrian paths. Exclusive pedestrian phasing coincides with a pedestrian scramble like we discussed earlier, and this allows pedestrians to cross diagonally. Split phasing is when vehicles have a split green phase and pedestrians have a short protected period when vehicles are not allowed to turn. Additional types of pedestrian signal timing include the leading pedestrian interval, or LPI. That gives pedestrians an advance walk signal before motorists are allowed to turn. LPI typically provides 3 to 6 seconds of advance walk time. LPIs should also include an available walk signal. A left turning phase can provide, which is another type of signalization, the left turning phase can provide a protected left-hand turn to minimize car and pedestrian conflict. And again, if you want to find out more about this information, you can go to the Pedestrian Bicycle Information Center that I mentioned, and the link is also available here on slide 14. So that was a general overview of the types of pedestrian signal timing that most of us see, and all that information, as I said, is available on the PBIC website. In terms of accessible technology innovations, I'm going to take a look at 2 recent pilots. One includes the University of Minnesota's Mobile Accessible Pedestrian Signal, or MAPS, application. MAPS is a smartphone application that assists pedestrians who are blind or who have vision impairments, and it helps or assists them to cross the street or navigate work zones. They can tap the phone app, which prompts audio information on intersection geography and signal phasing. And in the work zone situation, Bluetooth beacons can be attached to poles or barriers, and then that sends a vibration signal to their phone that's integrated with the phone's GPS to provide directional information to the pedestrian. Slide 16 provides an overseas example of a currently implemented technology that's targeted toward the older adults and persons with disabilities. This is the Octopus travel card that's being used in Hong Kong. Pedestrians who tap their card at designated signal poles can add 4 seconds of cross time to the light. And it should be noted that even though the Octopus is a travel card, no money is deducted from the Octopus card when it's used for the purpose of extending crossing times. So the 2 examples that I just mentioned are current high-tech examples or applications. And the opposite, if you will, example of a low-tech, non-signalized crossing would be the pedestrian flag system. You may have seen these in some cities across the country, particularly out west. I've used flags in Salt Lake City, Utah, and the example on slide 17 is from Kirkland, Washington. Pedestrian flags are yellow or orange flags that are carried by walkers. This is typically at mid-block crossings, and it helps motorists better see the pedestrian. So to do that, you remove a flag from the container on one side of the street, walk across the crosswalk, and return the flag to a container on the other side. This is an example of a low-cost, low-tech option in places where a signal warrant has not been met. And so what about the future of pedestrian crossings? On slide 18, we have a few examples of where LED lights are being used in Europe to make traditional crosswalks more visible. And in the Netherlands and Australia, strip, what they call floor lighting, has been placed in pavement to warn smartphone glued pedestrians who are looking down whether it's time to cross or stop. And this is typically an alternating green or red light that's found in the pavement. A much more advanced concept would be the United Kingdom's Starline crossing concept, where crossing patterns are lit on demand based on pedestrian path of travel and vehicle interaction. If you'd like to read more about the use of lights in crosswalks, I'm providing links on slide 19 to the Netherlands project, the UK Starline concept, as well as the example of the floor lighting that I mentioned that's for the smartphone users. The installation of accessible pedestrian signals and crossings is not without its difficulties. Whether or not a signal has been installed in a manner that's most accessible and safe for the pedestrian tends to vary municipality to municipality. The U.S. Access Board website contains an installation issues discussion with particular recommendations. Their website also includes Advisory Committee Report X02.5 if you'd like to read more on the subject of APS installation. Thank you to everyone who submitted a walking assessment from week 2. This particular week, Module 3's homework is to read the U.S. Access Board's Accessible Pedestrian Signal Installation Issues. The reading is 16 pages, but that includes photos. And after the reading is complete, then you'll want to take the module quiz, which is based on the homework reading. So this week, the quiz is based on the reading, not on the PowerPoint presentation that I'm giving right now. In terms of next week, that's when we launch into Module 4, and we'll examine national initiatives to improve pedestrian safety and accessibility. We'll also review the Federal Highway Administration's Safe Transportation for Every Pedestrian, or STEP program, which is a series of countermeasures used to improve pedestrian safety. And we'll look at recent research that reflects national trends and issues regarding the pedestrian movement. Thank you for listening to this Module 3 presentation, and as always, if you have questions, please email us at NADTC, so you can reach out to Rachel or Christy McLaughlin, or feel free to post to the course forum, and we'll get back to you at that location. Have a great day, and thanks for listening.